Okay, now I'm going to do an overview of our Compliant Modeler add-on. Here you can see is a model of an aircraft fuselage skin in blue and its tooling or fixture in green. This is the separated position, and the goal of this model is to move our fuselage skin to the tooling and fixture based on some clamp moves. Since our fuselage skin is a compliant part, we're going to use the Compliant Modeler. There are three methods for locating this skin. Over here on the left, you can see we're going to do a rigid body move, which will show you the basics. You can also do a DLL user add-on, which is part of the basic package, and that's called a segmented bend move. And what that does is bends corners based on bend planes that you can choose. And then we'll finally do our Compliant Modeler, and that's these last two moves here, and those will show you the final results, and you can compare those with the basic package. Right down here is our toolbar for the Compliant Modeler. There are many choices and options here for locating a compliant part, such as you can clamp, you can weld for here, you can position, or you can do a displacement and add force. And any of those options are available, but for this model we're just going to do clamps since it's a simple overview. Okay, the two steps for doing a clamp move are to first write an initialization move right here, you can see. And if I open it, it asks us for a mesh file and a stiffness matrix. And here you can specify which files you'll be using. You can import any mesh files from multiple programs such as HyperMesh, and you can generate a stiffness file within DCS with StiffGen, and I'll go into that next. And that's based on, you can use Abacus solvers, Nastran, multiple ones. So here you can see your parts, and you'll just apply your mesh files to these parts, and here you can create stiffness files based on these solvers, like I said, Nastran, Abacus, and that's all done internally. Then we have our clamp move right here, the second part, and with the arrows here you can see the different clamp points located on each of the tooling. And if I open it here, it's object target based, so we have our objects here. We have our objects on the skin and our targets on the tooling, and it clamps in the order that you choose. Okay, after we create these moves here, we then can add tolerances to each of the points. And as I scroll down here, these are tolerances on the tooling. We have tolerances on the skin that are not shown. And finally, I'm going to run the model, and so we can see the variation on each of the three different methods for attaching this skin. So if I turn on the tolerances, the first one is going to be the rigid body. So I have that one activated, and if I build it, you can see it's locating to the fixture based on these surfaces right here. And now I'm going to deviate, which again, deviating is just showing you the possible builds based on statistics. And here you can see the model skin is moving as if it were rigid to the fixture, and you can see it's not lining up great. This has exaggerated tolerances on it, so you won't actually be seeing this in the plant, but this will show you kind of how the motion is going. Next, what I'm going to do is show you the segmented bend. So I'm going to turn off the rigid body and turn on the segmented bend. And again, this one is based off of our user DLL segmented bend. And this one, when I build it and deviate, you'll see it looks a little bit better since it's folding along lines instead of purely rigid body, but again, it's not as good as we'd like to see. So now I'm going to turn on our final Compliant Modeler moves. And we also turn on our rigid body just so it locates to the fixture, and then it applies the clamps afterwards. Okay, so if I build it and deviate it, now you can see that the skin is deforming based off of its material properties and mesh. And you can see here, again, the tolerances are very exaggerated, and you won't be seeing this. This is just for demonstration so that you can see how it actually deforms. Okay. So after seeing these, since we kind of applied different tolerances to make it most visible for you, we also did a study that compared the three of these and the results of them. So if I pull up this chart here, you can see that we did a 6-plane move, which is the same as our rigid body move, and we did a segmented bend, the same as we just saw in this current model, and also we did the compliant modeler with clamps, the same as you saw again. However, in this case right here, we added measurement points, if I build it, along this inside of the skin panels and some on the outside. And we also made the tolerance, we made sure that the tolerances were equal on all points, so that we'd have a good comparison. When we ran it, this is our results. We had more accurate tolerances, so you're only seeing a 6 sigma deviation range, or your variation, around 3 millimeters tops. And with the 6-plane rigid body move, you can see the results are highest. You have the greatest range and deviation. Segmented bend was a little bit better, as we saw in the model. And finally, our compliant modeler was the best out of all three, and it has the lowest variation, even though all the factors were the same. So in this way, we can see that it's most accurate at predicting the variation of a compliant part, and the compliant part is key. These other moves are great for, you can use rigid for any other moves, but as soon as you deal with compliant, you can really see the advantage of using compliant modeler here.